Fishing services are frequently used to retrieve unwanted objects from the wellbore, such as tools or equipment, and twisted or broken sections of pipe or tubing. Fishing also includes the recovery of stuck drilling or production strings. Stuck drill pipe or tubing results in costly downtime and occurs all too often both in open hole and cased hole situations. The causes of string sticking are numerous. Sand or heavy mud in the wellbore can build up in the annulus to create sticking. During drilling and tripping, the string can wear a groove into the high side of an open hole. This groove, called a key seat, can lead to sticking in all types of wells. Differential sticking can occur when the hydrostatic pressure of the mud column exceeds the pressure exerted by a porous underground formation. As the mud filter cake increases in thickness, the likelihood of differential or wall-stuck drill collars also increases. There are other reasons for string sticking, but whatever the cause, the object in all cases is to determine at what point the string is stuck and at what point it is free. The free point can be determined with a special electronic free point tool run on wire line. The free point tool is securely attached to the wire line, and both are small enough to be run inside the stuck drill pipe or tubing. As the driller applies torque or stretch to the string, this free point tool measures the difference in pipe stress in the section between the two fixed points. The stress in the section of pipe is sensed by the downhole detector and electronically transmitted via the wire line to the surface panel, where it is displayed on a readout meter. The downhole free point reading is directly proportional to the amount of torque or stretch being applied to the string from the surface. After making a calculation to estimate the stuck point, experienced wireline operators begin taking readings slightly above the calculated stuck point. As the stuck point is approached, readings will decline until the detector is in the totally stuck section of the string, indicating no pipe movement. Through this method of data interpretation, a skilled wireline operator determines the free point precisely. Only by combining all available wellbore information with specialized training and experience can the expert operator compensate for various downhole conditions to determine the actual free point. Weatherford's unique free point detector, the Homco Stress Tector, has several advantages over other free point detection systems. The stress tector is extremely sensitive to torque and stretch. It can detect even subtle movement, including tension, compression, and right or left-hand torque. The ability to read left-hand torque is essential in certain fishing situations. Another advantage of the stress tector design is its durability. It can be run in combination with string shot explosives, which reduces the time involved in freeing the stuck string. A new version of the Homco Stress Tector, the Stress Tector 2, is being introduced for slim hole, coiled tubing, and high temperature situations. The smallest size Stress Tector 2, at 5/8 inch diameter, has been developed to handle pressures up to 20,000 psi and over 400 degrees Fahrenheit. Regardless of which detector is used, once the actual free point is determined, the free pipe can be removed from the wellbore after backing off from the stuck section of pipe below it. A back-off is made by applying left-hand torque and holding that torque while a controlled explosive charge placed across a connection is detonated. The explosion allows the connection to be unscrewed without damaging the threads. The freed pipe is then removed from the wellbore. It is often necessary to cut a section of pipe or tubing to remove it. Among the cutting tools available to Weatherford wireline operators is the chemical cutter, which uses hydrofluoric acid to cut pipe. The chemical cutter severs the tubing without leaving a flare or debris. This eliminates the need to mill or dress the top of the fish, making it easier to recover with an overshot fishing tool. Another cutting device, the jet cutter, severs pipe with a shaped explosive charge. Like the chemical cutter, the jet is matched to the size of tubing being cut. The jet cutter is also used to cut drill pipe, casing, and corroded or rusted pipe. The jet cutter leaves a flared fish top which must be milled or dressed off with a mill guide before the fish can be caught. Still another tool used in fishing is the severing tool. The severing tool utilizes a powerful explosive charge run on wire line which violently severs drill pipe, heavyweight drill pipe, and drill collars when conventional back-off techniques are not possible. The severing tool is recommended only as a last resort in expensive open-hole situations, such as offshore drilling operations. In open-hole operations, special wireline tools are used to perforate multiple shots per foot in a string of stuck pipe. Perforations are sometimes necessary to establish circulation to the annulus or spot lubricating fluid to help free the stuck pipe. Other specialized wireline tools are employed by Weatherford operators to aid in the removal of casing, drill pipe, or tubing. Wireline caliper tools are used to measure the inside diameter of downhole pipe. Occasionally, in open-hole fishing, junk may be too large and must be broken up into small pieces to be more easily retrieved. In these instances, a powerful explosive charge run on drill pipe is placed directly on top of the junk downhole. With the shot in position, a Go Devil electronic charge carrier is dropped inside the drill pipe. When it strikes the charge, it safely fires downhole. The smaller debris is then recovered. This first module in Weatherford's series on fishing operations has reviewed the techniques and common tools used in wireline pipe recovery operations.